Assalamu alaikum everyone, welcome to my YouTube channel. If you are new to my YouTube channel, please go ahead and subscribe and smash that like button. Literally, it is free to subscribe. You could always change your mind. With that being said, let's get down to today's video. So in this series, we're gonna build full stack mobile application. I have the mobile app demo on this side, and we have our architecture of the app on this side. So to show you what we're gonna build, this will be to-do app. So we did create a to-do, right, with the title to-do 1 and description 1. And once you submit, you'll see your to-do 1 on this on the home page. We can also edit to-dos. So if you click on it, you could edit to-dos and you could update it. After that, you will get updated. You can also set to-dos done. And after you're done, you can also delete. So we are building all of this together, but this video would be building our database architecture. So as you can see, we have our app architecture. We have the front end, right? The front end makes use of the API services, which makes call to database, right? In today's video, we're gonna concentrate building our database. So in our database, we're gonna build all of these layers. There are 3 layers we're gonna build together. So the client will make use of the API layer. So, you would put get, post, delete, just like how I showed you on the demo. And then this API layer would communicate with the service layer, and the service layer would communicate with the data access layer to make use of calling and fetching data from our database. And in this data access layer, we are gonna connect to a real database, which is postgresql. So we're gonna build all of this together. In the future videos, I'm gonna show you how to build the front end as well. So in today's video, we'll concentrate just building the database. So with that being said, let's get started. It allows you to create standalone production-ready apps. Some of the features that comes with Spring Boot are creating standalone Spring application. It has Tomcat embedded, provides you auto configuration and other external libraries. You could also check or monitor the health of your application. So Spring Boot is really powerful, which allows you to create Java-based applications. Spring Boot also has a Spring framework, and it is the framework we're gonna work with in this tutorial. So the framework provides comprehensive programming and configuration model for Java-based application. One of the best things about this framework is that it allows you to concentrate on the application level business logic without needing to put all of this extra boilerplate codes, right? Some of the features of this Spring framework is that it comes with dependency injection. Literally, it is so easy to inject dependency and use all these classes easily because of the framework. It takes care of all of that. You could also have event-based system, translation if you want to handle with multiple languages, validation, data binding, so on. It has testing as well. You can mock some of these objects. It also comes with data access, so it allows you to work with your database easily. And I'll show you how to do with all of that later on. It comes with only Java, Kotlin, and Groovy programming language as of right now. So Spring framework is really powerful. Alright, so I'm here on Spring Initializer website. This is where we can bootstrap our Spring Boots application. So from here, we could choose two different projects, Maven project or Gradle project. So we'll leave it as it is. We'll keep it Maven projects, and the list of language are Java, Kotlin, and Groovy. In this project, we're gonna work with Kotlin. If you are already familiar with Java, then Kotlin would be a lot easier. You get to do more while writing less code. So Kotlin is really powerful. Also from the Spring Boots, here are the latest versions of it. So this is the latest. By the time you're watching this video, if it is different version, then choose whichever is the latest. For the project metadata, we can leave it as it is. We're only gonna change the artifacts and the name. So we'll make it app, to do app. For the packaging, we'll leave it jar. And for the Java version, I have Java 11 installed, so I'll stick to 11. But if you have 17 installed, then you could choose 17. Now on this side, we need to add dependencies. So to add dependency, click on here, add dependency, or shortcut Command P. So if you click Command P, here are a list of dependencies we could choose, and this is huge. Like there's so much dependency to go over. But for us, we're only gonna work with Spring Web. This allows us to build RESTful APIs. So you click on that, select multiple or to choose multiple dependencies. It says here press Command and select. So for Mac, all you need to do is Command and then click on it. So here we're using Spring Web, so we'll click on that. We're also gonna work with real database. So we will search Postgres, so we'll click on that. And also, in order for us to connect to our real database, we need Spring Data GPA. So we will search, here we go. So Spring Data GPA will persist data in SQL. So it would allow us to get access to our database and to connect to our database using this Spring Data GPA. So command, click on that, and that's all we need for this project. So I'm gonna go ahead and share this project with you. So I'll click on here, copy, and then this will be available in the description link. Also, once you have all of this selected, go ahead and generate. Once you generate, you have app zip file downloaded. Click on that, show in Finder. It will take us here. Now double click on that. Now we have our to-do app downloaded, and here are the stuff. Next, we're gonna open IntelliJ. All right, so now what we're gonna do is we're gonna open IntelliJ. And now that we have IntelliJ open, click here, open. Go to your downloaded. And then from downloaded, we have to-do app. Here we go. Now open it. So now we have our project opened. Let's walk through the files. So most of our code would be source, main, Kotlin. This is where our application would start. And we have resource, and we have static templates and application property. In this property, we have to add some items to allow us to connect to our app. So if you go to the pom.xml files, and here's our list of dependency we downloaded. So we have our Spring Boot Starter Web, we have our Spring Boot Data JPA, and we have our also PostgresQL dependency, and we have Kotlin. So this all we need from here. Next, what we're gonna do is set up our application property, because right now if we run the app, we'll run into error because we need to connect to our database. So here it says that we have to connect to our database, and it failed to start. That's what we'll do next. Go to the application properties and paste this code in. So here is our data source URL. So we're gonna connect to PostgreSQL localhost 5432 and your username. This is my username, but use it for your local username. For MacBook, there is no requirement. Username and password is not required, but if you're on a Windows machine, make sure you create a database with username and password. Also, we are setting our JPA Hibernate to create drop. So whenever we rerun our app, we want to create a new database. So this is good for testing, because we want to test our database every time we restart the app. So this will give us a fresh database tables. Here we are setting show SQL statement to false. So if we want, we could set it to true. What this will do is, when we run our application, it will show us our SQL command onto the console. So set this to true, and then our Hibernate properties dialog, we're setting to PostgreSQL dialog, and also we are setting the format SQL to true, so we can see the SQL statement. And also, in case there's any error that happens in our server, then we would show the appropriate error messages. So make sure you add this code in your application properties. Also, you could find the code in the bio as well. Alright, so now we have our application running. Make sure you have Postgres installed. So if you don't have PostgreSQL installed, go to this website and download Postgres app. And once you download the app, it will automatically run on this port on your local host. So make sure you have this Postgres downloaded. After that, run the app and make sure you have this, everything is working well for you. So if you click run, the application now should start successfully. So as you can see, our application started on 8080. So if we go to our local host, so on our local host, this is what we see. So now we're gonna fix this to make sure we don't receive error web page. For the rest of this series, I'm gonna use Postman. So if you don't have Postman downloaded, make sure you download Postman for your MacBook if you have the Intel chip or M1 chip, or if you have Windows, make sure you have Postman downloaded. For me, I have Postman downloaded on here. So from now on, I'm gonna use Postman to do our APIs testing and all of this. So we have a server, but our server doesn't do what is expected it to do. We can give in any URL and it just throws an exception. What we need to do is to give in a specific URL and get a valid response. So we need to give in specific URL and get a correct or valid response. So by going to this endpoint, so by routing our request to this endpoint, we need to be able to get a valid response. So in order to do that, we need to use a REST controller. So let's go back to IntelliJ and create a new package, call it to-do. And inside this to-do, let's create a class, a Kotlin class, or if you're using Java class, but in this case, we're using Kotlin, and call this to-do controller. So what we need to do is that we want this to-do controller class to be able to handle requests. So in order to do that, we need to mark this to-do to REST controller. This annotation will let Spring know to map the URL we're trying to access and what happens when we receive a data to that URL. So we're gonna use another annotation, request mapping. So we want to map all of our requests to this URL, API1, API v1 to do. So we are mapping all of our requests to this endpoint. Now we'll create a function which gets all of the to-dos, get to-dos. This function should return a list of to-dos, list of to-do, and then we can create a list of return list of to-dos. So to-do. So we need to create a to-do object. So go to here, create Kotlin file, and let's create a data to-do. So a data class, what it will do is it will only create the objects we need. And this data class comes with toString, toCopy. So it's just handling the business logic for us. So now that we have our objects defined, our to-do object, so let's come here and in this to-do, let's create ID. So let's pass in. So now I have added 3 to-dos. So what we need to do is when we hit this endpoint, we will need to get this to-dos, which is list of objects. In order to do that, we also have to create GetMapping. GetMapping. This GetMapping is another annotation which maps the URL we're trying to request. So in this URL, we will map get. So when we call API v1 to-do /get, this URL is getting mapped into this get to-dos method. So when we hit this endpoint, we are calling this method, and this method will return as a list of to-dos. So let's go ahead and restart the app. Now that our app is restarted, let's go back to our postman and let's request. So now, once we send our request, we receive a list of to-dos. So now this endpoint is working as expected. Next, let's talk about services. Alright, so we kind of map this get URL to this get to-dos method. So whenever we send a request to this URL, we are returning a list of to-dos, and we have to keep on creating new to-dos every time we send this request. So now what we need to do is to create a service which will return as a list rather than creating a to-do list every time we send a request to get to-dos. So let's go to to-dos and then create a class, call it to-do service. Now this class, we have to mark this class as a service in order for Spring Boot to initialize this class. So we have to use annotation service. So this annotation tells Spring Boot, hey, this is a to-do service, so please create an instance of this class and register it in the memory. So the classes that are dependent on this service will get initialized and then it will get injected. So all those classes that are dependent on this service would be able to use it. Just like that, Spring would know from the class path that, hey, we have a to-do service which is marked as service. So now go ahead, create an instance of to-do service and register it in memory. Now in order to use it, we have to go back to to-do controller and create a file to-do service. Now, when Spring Boot is initializing this controller, it would check its properties, to-do service. Now it said, oh hey, we have a to-do service class and this class is marked as a service, so now give this controller an instance of to-do service. Now all we need to do is return to-do service dot get all to-dos. Now we would have to create this method inside to-do service class, create this method. Now what we will do is we'll just return a to-do service here. So now it is really clean. Whenever we get request, it would map it to get to-dos, and these to-dos will just return all of the to-dos inside of service class. So now go ahead and start your server. So we have our server up and running. So if we go to Postman and send a request, we will get all of the to-dos. Okay, so we kind of built the API layer together. We just haven't implemented all of this CRUD operation yet. We also built the service layer. Now what we need to do is build the data access layer so that we can connect to our database. So next we'll do that together. So in order for us to connect to our data access layer, we will need to use Spring JPA. So in order to do that, let's go to IntelliJ, and now in our class, in our to-do class, let's mark this class as entity. By making this class an entity, we are telling Spring JPA to make a table out of this class. So all of these properties is then translated into a table where we can insert data into our database table. So right now, as you can see, there's a little icon. If you click on that, preview, you can see that we're gonna make all of this property into a table. Right now we're having an error. It says that we need to have a primary key. So in order to do that, we can add another annotation which is called ID. All of these are coming from Java persistence, ID, and entity. So this is coming from Sprint JPA. So now our error is gone, and now our ID would be our primary key. We also want to make a table out of this object, or out of this to-do class. So we can also add another entity which is called table. So now we transform our to-do object into a table in our database. So now the magic part is to create a new class or an interface and make it to-do repository. So now this to-do repository extends from JPA repository. So if you look at this JPA repository, it takes a type and an ID. So this is a generic. So we need to tell what type it is and what is the primary key. So our type or the data we are working with is to do. And the ID is our primary key. So if we go back to do, our primary key is ID, which is of a type long. We tell Sprint JPA that our primary key is of a type long. Just like that, it is done. Now let's look at the JPA repository. Out of the box, it gives us all of these methods for free. We don't have to implement anything at all. We could delete, we could find, we could save. So this is the CRUD operation, and we'll work with it in a bit. All right, so now that we have set up our JPA repository, go ahead, restart your application. Okay, as you can see, we have to-do table created. All right, so now we are gonna open postgresql. If you have it showing on your toolbar, you could then select the element icon and then open Postgres. If you don't see that, just check your Spotlight search and then search Postgres right here, this one. So now that will get opened up. So I have Postgres opened. So now this is the database we are connected to. So my username. So I will double tap that. All right, so I have terminal opened. So we can run some commands. So we can see list of the database we have. So we have this database table, we have Postgres, and we have other template ones. We could also check users, and here are list of users we have. We have Postgres and my username, right? So we could connect to this database. So connect, and then this database we created. Now we are connected to here. So now we could see tables. Now we only have this table to do, of which is a table, and the owner is this user. So we have our to-do table inserted successfully. And if we, right now we don't have anything, so if we select from table, to do, sorry, we have our IDs, description, done, and title. So we have no items inserted, but we have our database table and columns, and everything is good to go. Alright, so now let's connect to our local database in IntelliJ. So go to your database here on this icon, click on that, click on this plus icon, select data source, and there's many data source, but for now we are using Postgres, and then use your username. So my username was this Mohammed Bashir. This was the database we connected to. We can test our connection. Everything is good. Apply, and then OK. So now we connected to our database using IntelliJ. If you refresh, let's see if we have any table. Here we go. And now we have our to-do table, and we can see the columns, right? If you double click, we have our columns, ID, description, done, right? And we have our primary key. So everything is working as expected. So we have our database connected in IntelliJ. Also can access our database using terminal. So whichever works for you the best, you could go ahead and use. For me, since I have IntelliJ Ultimate Edition, so I'm gonna be using my database through IntelliJ. Okay, so we created our database. We also created this table in our database, but there's no item in it. So let's start inserting some items so we could see it. So go to your to-do app application file in this application. So what we need to do is whenever our server runs or whenever our server starts, we need to populate some items and insert those items in our database. So to do that, go to your to-do application class. In this class, we'll create a method and we will mark this method as a bean. So add bean, import that, and then we'll say fun in it. Let me turn off the GitHub Copilot. All right, so we created a method in it, and this method takes a to-do repository, our repository, and then we'll import this, and then we'll also import this command line runner. So this command line runner will execute whenever our server starts. So at the beginning, when our server starts, this command line would execute and retrieve all of the beans, all of our objects, and then we would save our objects or we would insert our to-do object in our database. So let me format this for you guys so it is easy to see. So we created 3 to-dos objects and we're saving each object to our database. So we are inserting. So this save means insert. So we're inserting our to-do object in our database. If we restart our server, so if you go here, restart the server, we should see these 3 to-do objects inserted in our database. So if you see, now there is this SQL command where insert into, so we're inserting into to-do table where the values of these values are inserted. So if we refresh our database and go here and then click on here, we have our to-do objects inserted. So all of these are working. We can also query if you want. So if you want to query, go click on this plus icon, query console, and then we just select. So select all from to do. So once you execute or when you run this, we receive our to do data inserted successfully. So This now works great. We have items inserted. Now what we need to do is to go to our to-do service and query those data from our backend. Every time we call this to-do, instead of creating new to-do objects, what we need to do is get the data or fetch the data from our database. So this is what JPA will do. JPA will retrieve those data, convert them into a to-do object, and gives us those objects. So it would do the data mapping and data transformation and give us the object we need. Okay, so let me minimize this. We don't need this. So in order for us to fetch data from our database, we need to get access to our to-do repository. So we need to get access to this repository in our to-do service. In order to do that, we can auto-wire an instance of to-do repository. I will show you two ways to do this. First way is to create private file to-do repository. To-do repository, which is to-do repository. This would work. You just have to annotate that this is auto-wired. This will be auto-wired. Right now it is asking us to initialize it. So we could add an initializer, but we don't need to do this. We want Spring to initialize it for us. In order to do that, you just have to make this late for init. This is one way to do it. And this would be the Java way. But in Kotlin, we don't need to do this. We did get an instance of our to-do repository injected just like this. Now we have injected our to-do repository inside our to-do service. All we have to do is return to-do repository dot find all. So this find all method, if you look at it, it will return a list, right? It will return a list. So for us, it will return a list of to-dos. We have this implemented. Let's fix this. Let's rename this to get all to-dos. So now we rename this get all to-dos. And now we are using our to-do repository to retrieve all of our to-dos. Now in our controller, all we have to do is call the get to-dos. And now when we hit this endpoint, this method will get executed, and then it will return, or it will call this method. This method will return us a list of all our to-dos. Let's go restart the app, and now we'll go to Postman and query. We'll send a query and see what happens. All right, now we're back to our Postman. So we send this query on our localhost 8080 API v1 to do get. So when we send, we return a list of all to-dos. And this data are directly coming from our database, our backend. So now we have actually implemented all of these layers. Now we just have to implement the logic. We kind of implemented get. Now we need to implement post, delete, put, and just finish on our CRUD operation. But everything else is all connected, and we have implemented all of these layers together, and now it's just a matter of implementing the rest of CRUD operation, and we'll do that next.